Defining and using sequences. Your state standard is listed first, and then your success criteria. To be successful in this lesson, you need to use your rules to write terms of sequences, graph sequences, and write rules for sequences. There are two new vocabulary terms. A sequence is an ordered list of numbers, and a term, each number in a sequence is called a term. So if you have a sequence, each number in that sequence is called a term. All right, here's an example of a sequence. You've got 5, 10, 15, 20. You can see that this is your first term. It says first position. This would be your first term, your second term, your third term, etc. Example 1, writing the terms of a sequence. This one says to write the first 6 terms of each sequence. So remember, n is going to be the number of terms. So we can, this is the part on the left, a sub n. That's kind of like the name. That's what you're looking for. That's the name of the sequence. So each time we change the number, or we'll change n to represent the term that we're actually looking for. So we're going to say a sub 1. That means your first term. So we're going to have 2 times 1 because we're plugging 1 in for our first term, and then plus 5. So the first term is 2 times 1 is 2. 2 plus 5 is 7. So my first term is 7. And then I'm going to do that. I'm going to repeat that 6 times because it says find the first 6 terms. So now I want to find my second term. And again, the part here on the left, a sub n, this is kind of the name of the function. It's kind of what we're looking for. So this is our second term. So we're going to do 2 times 2 plus 5. So we got 4 plus 5, or 9. Now we're going to do the third term. 2 times 3 plus 5. 2 times 3 is 6. 6 plus 5 is 11. So now we've done 3. We need 3 more. So we're going to do our fourth term. 2 times 4 plus 5. 2 times 4 is 8. 8 plus 5 is 13. Then we're going to do our fifth term. 2 times 5 plus 5. So we've got 2 times 5 is 10. 10 plus 5 is 15. You should also see a pattern happening right here. But we're going to do one more. A to the 6th, a sub 6. This is our 6th term. So 2 times 6 plus 5. So we've got 2 times 6 is 12. 12 plus 5 is 17. All right, B part says f of n equals -3 raised to the n minus 1. We can say that this one is exponential since the variable is in the exponent position. But it's going to work exactly the same way. So we're going to say f of 1. It's going to be our first term. And we're going to substitute 1 in for n. So we've got -3, 1 minus 1. So it would be -3 to the 0 power. Properties of exponents, anything to the 0 power is 1. Let's do the second term. So f of 2 is our second term. So we're going to have -3. And then n is 2 in this case. So 2 minus 1. And that's going to be -3. 2 minus 1 is 1. Anything to the first power is that number. So it's just going to be -3. We're going to do our third term, f of 3. So we're going to have -3. N, in this case, is 3. So we're going to have 3 minus 1. So we're going to have -3. 3 minus 1 is 2. So -3 squared is 9. Remember, when you square a negative, it becomes positive because that's the same thing as -3 times -3. All right, we're going to do our fourth term. So we got -3 raised to the 4 minus 1. So we've got -3. 4 minus 1 is 3. All right, so we've got -3 to the third power. That's going to be -27. Remember, that's the same thing as -3 times -3 times -3 a third time. All right, and then we've got our fifth term. So we're going to have -3, 5 minus 1. So we've got -3 raised to the fourth power. Again, when this is an even power, it means it's going to be positive. And when you're raising something to a power, you can think of this -3 squared. So it's going to be 9 times 9. So this one's going to be 81. So it's good to be able to see how numbers connect as well and see patterns form. All right, so you got f of 6. This is the last one. So we've got -3, 6 minus 1. So we're going to have -3. 6 minus 1 is 5. So we're basically going to have 81 times -3. -3 to the fifth power would be the same thing as 81 times -3. So that's going to be -243. All right, so there is a pattern here as well. It's not as easy to see as adding 2. But again, this one is exponential. You can see it goes from -3, +9, -27, +81, and -243. Example 2, graphing a sequence. Graph the sequence 1/2, 2, 9/2, 8, ... Okay, so we know that this is our first term. So again, to graph, you have to have ordered pairs, x and y. So let's go ahead and make a table. So we know our first term is 1/2. We know our second term is 2. We know our third term is 9/2. And our fourth term is 8. All right, so this is the position. This is the n. We'll call it and then this is the actual term. So this would be your A sub n. All right, so now that we have ordered pairs, to graph ordered pairs, you simply go over here. We'll go to term 1 is 1/2. So let's put a dot at 1/2 here. And then 2, 2. And then 3 and 9/2. So you got 2, 4, 6, 8. So that's 4.5. So at 3, we're at 4.5. This is 4, 5, 6. So 4.5 would be right in here. And then we have 4, 8. And if you wanted to continue that sequence, you could find that pattern and write that formula, which we're gonna learn how to do very shortly. So that's how you would graph example 2. Example 3, writing rules for sequences. Describe the pattern, write the next term, and write a rule for the nth term of each sequence. All right, so the first thing we're going to do is look for a pattern. It says describe the pattern. So we've got -1, -8, -27, and -64. So when I look at these numbers, I think of different things. 8 is 2 times 4, but it's also 2 to the third power. 27 is 9 times 3, but it's also 3 to the third power. 64, 8 times 8, but it's also 4 to the third. It's 2 to the sixth. So you have to have some kind of number sense. You have to be able to recognize what numbers can be rewritten as. All right. So let's look at a couple things here. So -1, we could write that as -1 to the third power. -8 could be -2 to the third power. And I recognize the pattern. All of these, if I look at them, could be cubed. So that's where my mind is going. So -3 cubed is negative 27, and negative 4 cubed is negative 64. All right, so it does make a difference too whether the negative's on the inside or outside. All right, so this is negative 3 times negative 3 times negative 3. And same thing with all of these. All right, so now it says to write the next term. So the next term would be negative 5 cubed would be negative 125. So that identifies what your pattern is. And then it says to write a rule for the nth term of each sequence. So we can say that a to the n, this is usually the hard part for people, but remember a to the n just remembers that's like the name of your function. So a to the n, and we can substitute any number we need in n. That's the term, remember. So we're going to have a to the n equals, and then it's going to be negative. And then what did we change? We changed this part right here. The negative kind of stayed consistent with our sequence. So we're going to have negative n raised to the third power. So this would be our rule for sequence for part A. B part is 0, 2, 6, and 12. So again, we're trying to describe the pattern. We're going to write the next term and write a rule for the nth term. So 0, let's come back to 0. 2 could be 1 times 2. 6 is 2 times 3. 12 is 3 times 4. So let's kind of write that down and see what it looks like. So we're going to have 2 is 1 times 2. And then 6 would be 2 times 3. 12 would be 3 times 4. And if we come back to 0, we could write 0 as 0 times anything. Kind of looking at what we have, we've got 2, 3, 4. Let's put 0 times 1. All right, so we have 0 times 1, 1 times 2, 2 times 3, 3 times 4. So what do you think our next one will be? So 4 times 5. So let's say 4 times 5 would be our next term. And that was going to equal 20. So 20 would be the next number in the sequence. All right, so now we want to write a rule. All right, let's write a rule. So we're going to say either f of n or a sub n. Let's say f of n equals. And then what do you notice here? So you got 1, 2, 2, 3, 3, 4, 4, 5. And if we went to the next one, it would be 5, 6, 6, 7, etc. So you could continue this pattern. So what rule or what equation represents that? So if you see that the numbers here, the first number is always 1 less than the second number. So for an equation, we would write n minus 1 and then times n. So this would be our n. This number is n minus 1. All right, and you could check it. Again, check it for 4. Our fifth term. So you get 5 minus 1 is 4. And then 4 times 4. Well, let's see. Okay, that's right. So n would be 5. Okay, so let's try that again. I'm just checking my work here. So 5 minus 1 is 4. 4 times 5 is 20. And we know that's what the next one should be. We already determined that. So that is your rule or your equation that represents this sequence here. So this rule, always check it. You know, sometimes you have to play with it a little, but if you check it, it should work for each one of those terms.